In this lesson, I'm going to be talking about absolute versus conditional convergence of different series. So, the first kind of example I want you to think about is this one. So if I plug in 1, I have the cosine of 1 over 1 plus the cosine of 2 over 4 plus the cosine of 3 over 9 and so on. And I looked up these values in my calculator. And you see the values are getting a little bit smaller. When I add in the next term that I didn't write up there, we get that. We need a way to prove this is converges. So, absolute convergence. We can say a series is absolutely convergent if the absolute value of the series also converges. So therefore, then the regular series is going to converge. So really, this is the big thing you want to keep in mind. You're absolutely convergent if your series converges. You're conditionally convergent if your absolute value diverges, but your regular one converges. Oh, what's that? Okay, so let's look at it. Let's revisit this example. Determine whether the series is absolutely convergent, conditionally convergent, or divergent. So I'm going to look and see the absolute value of the series. Okay, and we're going to compare this. One over n squared. So let's look at this. I know the cosine of n over n squared, the absolute value of that. Well, cosine goes between positive and negative 1. With the absolute value signs, I know that this is going to be less than 1 over n squared. I know the smallest it could be is 0. So now looking at this, so using the direct comparison test, we know that that function's smaller, so we look at what happens to this series. And this converges by the p-series test. So then we know that this absolutely converges. And I'm going to write the series one more time just so that it's super clear. By the direct comparison test. Okay, next example. Determine whether this absolutely converges or conditionally converges. So what you want to look at first is look at the absolute value of it. Well, when I'm looking at the absolute value of that, I'm really looking at what that series is. Well, this series converges by the p-series test. So my original one converges at absolute. I cannot spell tonight. Holy cow. Absolutely. Hopefully that's not a horrible spelling. I apologize. Okay, next one. Determine whether this series is absolutely convergent, conditionally convergent, or divergent. So again, let's look at the absolute first. Okay, so when I'm looking at the absolute value, I really have n to the e. On the top there, I really have -1 to the n and then e to the n. So the absolute value is really just going to look at that series. Now when I look at this, limit as n goes to infinity of this diverges by the nth term test. So then now I look at, see if it's conditionally convergent. So I look at it like this. And this is an alternating series, and each term is getting smaller. So I use my alternating series test. And my alternating series test, and I checked that the values were getting smaller in my calculator. I look at this, and this goes to infinity. Again, both the limits go to infinity, because an exponential is going to get bigger faster than something to the e power, which is like 2 point something power. So e to the n is going to get faster, is going to grow at a faster rate. So this fails. This series diverges. And that's the examples we're going to do in class. We're going to do 3 more if you're in my class to kind of see. It's kind of like a check your knowledge type of thing.